Today we'll be learning how to factor out the greatest common factor of a polynomial. First, to factor out a greatest common factor, determine the largest number that divides evenly to all coefficients and what variables are common to all terms. Now we ask for it to be evenly so that we can have whole numbers that we are working with instead of decimals or even fractions. But those are possible. But we'll learn that in a later lesson. The very first step in factoring is to always identify the greatest common factor and factor it out, also known as dividing it out. Now for these purposes, we are setting it up to where it is beneficial for you to factor out the greatest common factor. So we're going to stick with that. Now in doing so, say when we just have integers, one of the first things we can look at and see if our smallest number, the 4 in this case, can divide our 12. Is 12 divisible by 4? At this point, we should know yes, it is. So that means that our greatest common factor is the number 4. So if I were to write this out, I just need to write out what the greatest common factor is. In this case is the 4. Now sometimes it's not that simple, such as 18 does not divide 27, and now we have a variable in it. We understand that we can break the variable down based off its exponent, so we're going to use that as well. Variables are pretty simple. You simply take the smallest value, exponent-wise, of them. Each term has at least one y in it. So if I were to look at this, I could see that this is 27y times y. And now I can see that they both have a y that I could factor out. But with the numbers, it's a little different. I need to know what the factors are of each number. Now, if you don't know, you could always create the factor tree, or factor table, sorry, not tree, and break it down. We know 1 in 27. It is not even, so not 2. 3 and 9. 4 doesn't work. 5 does not work. 6 does not work. 7 does not. And 8 does not. So in this case, these are the only factors for 27. And then we can do the same thing for 18. Now, if you have an understanding of how factors work, you may already know what the largest factor is. But just to show everyone, we break every one of these down. But here, we can see the largest number so far is our 9. I can break this down even further. 3 and 6, it's not divisible by 4, 5, and then we're back to 6. So our largest common factor, in this case, is 9. And the one y that both factors have. So to break it down in its simplest steps, you can take each number and create the factor table and find which factor, common factor, is the greatest, just as the name states. Now you can do this with a negative as well. In this case, we have a negative 4 and a negative 8. We know that the 4 can divide the 8. So we can use the negative as well. Depending on situations in later lessons, we will factor out the negative or leave the negative as a part of the factor. But in this case, we want to factor it out. And then yet again, we have a squared and a. Our lowest exponent of a is 1, so we can only factor out 1. Now the way this will look in our polynomials, we kind of follow the same steps of what we're factoring out, but the way we set up the expression is going to look a little bit more organized. If I look at 27 and 18, I can break those down because 18 does not divide 27. One and 27. 9. We've already done it up here. We know that the last one is 3 and 9. And 18, let's do a little shortcut. If I can loop everything. We have the same numbers. So looking at this, I know that I can factor out the 9. They both have a y variable in the term, so I can factor that out. So whenever I say I factor it out, what I'm doing is pulling it out of each one of these terms. Now to show that it was factored out, we need to show that it can multiply into each one and what's remaining. So in this case, our 27y squared. What was left was the other y and a 3. So our first term inside the parentheses is what is left after we divide by 9y. And we'll do the same thing for the second term. What would be left if we divide by 9y? The y would cancel out, and our 9, we can see over here, would leave the 2. Now I can check my work and distribute back in. 9 times 3 is 27. Y times y is y squared. And then 9 times 2 gives me 18 with the y still there. So it checks out. So this is the point of us pulling out the greatest common factor. It's to help us work with our polynomials. We can do it with the negatives as well. We know that we can pull out a negative 4a. If I divide the first term by negative 4a, that would leave me with a positive a. And for my second term, if I divided it by the negative 4a, this would leave me with a positive 2. So since we pulled out the negative, both of my terms became positive. Negative divided by a negative is positive. And then I divided by the a, which leaves 1 power of a in the first term, and it cancels out in the second term. And last but not least, our number 4 divides, cancels out in the first term, and leaves 2 as our factor. Now in some cases, like number 5, there is not a common factor other than 1. So our simplest form of this is just the answer. So for now, we are learning how to pull out the greatest common factor when we do it with a polynomial to keep it organized, leaving it in an expression. Whatever factor, greatest common factor we are using, we write on the outside of parentheses. This is the opposite of distribution property. And then whatever remains, we rewrite on the inside. Our 3 and y for the first term, and then our 2 for the second term.